All right, let's talk UML class relationships. If you've ever stared at one of those diagrams and just felt your brain start to melt, you are in exactly the right place. Honestly, they can be a total headache, but I promise you, we're about to make them super, super simple.
And I really want to start with this because it's so important. If you've struggled with this stuff, let me be clear. You're not dumb. You're not alone. It is not your fault. It's the way it's usually taught that's the problem. You know the drill, right? Most classes just throw this mess of confusing arrows and diamonds at you and expect you to just memorize them. There's no intuition, no why behind any of it. It's a totally flawed system, and we're going to fix it right now. So, I want you to forget everything you've tried to memorize before. We're doing a full brain reset. We're going to install a new, way simpler framework. It's just 2 questions. That's it. And these 2 questions will get you the right answer every single time, even on an exam. You ready? Okay, so we've all felt it, the UML headache. That's the problem. Now, let's finally get to the cure. And here it is. This is the absolute core of the entire method. Seriously, everything you need to know about UML relationships, it all boils down to just 2 key questions. This is your starting point every single time. Before you even think about a symbol, you just look at the 2 classes and ask this one simple question in plain English. Is this an ISA or HASA relationship?
And I really want to stress this. That's it. Your entire journey to the right answer, it all hinges on this one decision. Get this right, and I promise, everything else just clicks into place. So once you answer that first question, you're sent down one of 2 paths. One path leads you to arrows, the other leads you to diamonds. Let's walk down that first path together. So if your answer to that first big question is, congratulations. You are always dealing with inheritance. And the symbol for inheritance? It's just this simple, hollow arrow. And you can already see how intuitive this is, right? Just say it out loud. A dog is a animal. Yep, makes sense. A student is a person. Of course. If the sentence works, if it sounds right, it's inheritance. Simple as that. And here's the little memory trick to just lock it in your brain. If you can say is a, you draw an arrow. That's it. Is a equals arrow. Now what about the other path? Let's talk about the has a relationship. Okay, so what happens if your answer to question 1 was has a? Well, that's easy. It just means you have one more question to ask. And this is our second key question. If the whole thing is destroyed, does the part die with it? Your answer here decides which diamond you're going to use. So if the answer is yes, the part absolutely cannot exist without the whole, then you have what's called composition. This is a really strong ownership-type relationship, and it's represented by a solid, filled-in diamond. Just think about it for a sec. A house has rooms. If you demolish that house, what happens to the rooms? They're gone, right? They don't just float around in space. The part dies with the whole. That is composition. Here's a super powerful way to remember this one. A full diamond means full control. The whole class has total control over the part's entire existence. So if the whole goes, the part goes too. Just remember, full diamond, part dies. But what if the answer to our question is no? What if the part can actually survive on its own? Well, then you have aggregation. This is a much weaker relationship, and it's represented by a hollow diamond. A classroom has students, right? Makes sense. But if you dissolve that classroom for the summer, the students don't just disappear. They still exist. They go on to other classes. They survive independently, and that is aggregation. And this slide right here puts the 2 most confusing types right next to each other. Look. The only thing you ever need to ask yourself is this. Does the part die with the whole, or does it survive? For composition, that full diamond, the part dies. For aggregation, the hollow diamond, the part survives. That's the entire difference. That's it. Okay, so the theory is down. We've got it. Now let's see this simple framework in action and watch how it makes a typical exam question, well, kind of laughably easy. Here we go. A classic problem. A little paragraph with 3 different relationships to figure out. Now, instead of panicking, we're just going to apply our 2 questions, 1 sentence at a time. Let's break it down. First sentence. A teacher is a person. That's a textbook ISA, so it's inheritance. Easy. Next. A department has teachers.
Okay, that's a HAZA. So we ask question 2. If the department shuts down, do the teachers vanish? No, of course not. They survive. So that's aggregation. And finally, a university has departments. Another HAZA. If the entire university closes down, can the physics department exist on its own? No, it's part of the university. The part dies with the whole. That's got to be composition.
And just like that, there it is. We solved it. A teacher is a person, inheritance. A department has teachers, but they can survive without it, aggregation. And a university has departments which cannot survive without it, composition. See? No guesswork, just a clear, repeatable process. So if you remember nothing else, please just burn this one line into your memory. This is your cheat code. Arrow means is A. Diamond means HAZA, and if that diamond is full, the part dies. If it's hollow, the part survives. That is the entire system in one sentence.
You know, this whole framework, this idea of breaking a really complex problem down into a couple of simple sequential questions, it's incredibly powerful. It really makes you wonder, doesn't it? What other tough subjects that seem totally impossible could actually become simple if we just figured out the right questions to ask?